Recording. Right, team. Let's fill a couple of things in. So in order to sketch, it's usually a 3 marker. So when you're doing your papers or your sacks, I'll be marking on 3 things. So hence, you only need to find 3 key features to sketch a quadratic graph specifically. You will need to find the axis intercepts, okay? Actually, sorry, let me say y-intercept. You may get 1 or 2 or no x-intercept, and then turning point. But just as part of your notes there, usually the marking scheme, especially when you get to year 12, these are your 3 marking schemes in order for your sketches. If you do all these 3, then you shouldn't lose a mark at all. But here we go. Mark number 1 usually comes to what we call axis intercepts. At year 11, I guess we can give you a bit of marks depending on which one it is, but I usually stick to these 3. Axis intercepts means you have to include both y and x. Number 2 is any key features. With a quadratic graph, turning point is a key feature. And then number 3 is the shape of a graph. It means that if you're doing a linear equation as an example, and if you were used to drawing it by hand and it looks kind of like that, you lose a mark. It has to actually show that that section does not curve. A linear has to be straight, so hence you should be using a ruler to sketch straight lines. Okay, so if you're doing a chapter 1 sac later on, which I'll talk about soon, I'll be looking for shape, axis intercepts, and any key features. Okay, so sometimes key features in a straight line could be endpoints. So you might say a starting point to an endpoint. So I'll be looking if you labeled an endpoint. So that's what key features represent. Later on, as you learn more graphs, then there are asymptotes, there are inflection points and endpoints. Those are the things that you'll have to look at. Okay, so those are your 3 key general marking scheme when you're sketching. Let's take this as an example. Let's go with the first one. So you got 3 key features. Exercise 3F wants you to sketch all types of quadratic equations, and usually they're in their general form. It's up to you how you want to sketch it. Okay, so whether you want to use the turning point form to sketch, or whether you want to just stick to general form, that's up to you. I actually use both forms, and that's because I can do all of the algebra there. Okay, so here we go. How do we do this? We need axis intercept. So the first thing is, what's the beautiful thing about general form? How do I know this is general? Because there's 2 x's. Turning point form only has 1 x. Yeah, what you did yesterday. So what's beautiful about a general form? You can find the y-intercept straight away. Because how do you find the y-intercept again? What do you do? Yeah, so x is 0 and you don't know what y is. So essentially you're saying, let x equal to 0. So if you have a general equation, usually if you just substitute 0 in, which you cancel it out, makes it pretty straightforward. In our case here, just looking at the equation there, what would my y-intercept be? What's y equal to? 0. So therefore your y-intercept is at 0, 0. So I should already have a point labeled in coordinates 0, 0. Notice the question, coordinates. You don't put in coordinates, you lose a mark. Okay, so when they say coordinates, make sure to put in coordinates. As a habit, I always put them in coordinates. You can't get penalized for that. Okay, so I got the y-intercept, that's great. I need now the x-intercept. How do you find the x-intercept again? What do you do? How do you find the y-intercept? Let's go with Zoe. You let y equal to 0. So you let y equal to 0. So in your equation now, it becomes 0 is equal to x squared minus 6 times x. And this is what you've been doing in exercise 3C. You can't solve these equations easily because there's 2 x's. So the first skill that you'll be doing in exercise 3B and 3C is to factorize. Let's factorize it. Lucky, how do I factorize this?
You just factor out x.
Good. X is the only common factor within those 2 terms. You don't have to do cross method because it's not trinomial. So taking out at x, I've got x times x minus 6. And then going back to exercise 3C, you're going to solve it now. Luke, what are my answers? No, that's okay. Let's go, Anthony.
X is 0 and X is 6.
Very good. And again, remember, null factor law says something times something. If the result is 0, one of them has to be 0. So we're saying, all right, well, what if it was this one? Well, then you end up with x could equal to 0. Or you may end up with x minus 6 could equal to 0. Because we just need one of them to equal to 0 to make this whole thing equal to 0. So if I solve for it, well, this one is nice. It's already x equals 0, so I don't have to do anything about it. But on this side, I need to solve it. So let's solve it. Let's go with Kai. X minus 6 equals 0. How do I solve for x? What do I do?
Move 6 to the side.
Good. And that becomes?
6.
6. Great. Because that's minus 6. Opposite of that is plus 6. So if you add 6 on both sides, that cancels out. And that's why you get x equals to positive 6. What does that tell me? That tells me I've just solved. When will I have y equal to 0? Will you have 0 when x is 0? Or you have y equal to 0 when x is 6. So that means you've got two coordinates. One is at 0, 0, and the other one is when x is 6 and the y is 0. Which makes sense because you already got the y-intercept, which is 0, 0, and it also happens to be the x-intercept as well. So I've got now one point, which is here, 0, 0, and the other point is at 6, 0. I'm missing the turning point. Now there's many ways to do the turning point here. I can think of 3 already. Method 1, you could do completing the square, what you learnt yesterday, to then change it to a turning point form, and then you can read out where the turning point is. Or you could use the formula I gave to you yesterday, which we haven't practiced yet, out of curiosity. Anyone remember that formula that I gave to you? The formula is x equals to, gives you the x coordinate of the turning point. So negative b on 2a. Very good. So for those who didn't know, this is yesterday's last bit of yesterday's notes. X equals negative b on 2a. I can't prove it to you until the end of the year when you do calculus. But if you've got a general form, b is the number in front of x, a is the number in front of x squared, and then c is your constant term. So if you wanted to find the x coordinate of the turning point, because remember turning point has x and y, you can find that x coordinate by using this formula here. Okay? And if you know the x, how do you find y? Let's say if I hypothetically said the x coordinate was, what's middle between 0 and 6? So that's like 3. Let's say the x coordinate's 3. How do I find y? Yeah, because you've got an equation. It says, if you know what x is, I'll tell you what y is. It says y will equal to whatever x is. If you found what x is, sub back in. 3 squared minus 6 times 3 will give you the y coordinate. So that's how you would find the turning point. That's method 2. Method 3 is what I just did just now. Did anyone see how I figured out it was 3? What did I do? So I said method 1 was change it to turning point form. Method 2, using this x coordinate turning point form. This is called axial symmetry formula. And the third method, how did I know the turning point? The x coordinate is going to be 3. Sion. Yeah. Remember, quadratic graph is symmetrical. We already found the x-axis intercepts at 0 and 6. So if I had to picture it, it doesn't matter if it's a frown or whether it's a smiley face. The point is it's going to be symmetrical. If it's going to be symmetrical, it must be in the middle of 0 and 6. The middle of 0 and 6 must be 3. Okay, so that's the other one. That's a method 3 where you're using intuition. We know that the turning point has to be somewhere in the middle, so the x coordinate must be 3. Again, if you didn't trust that, you can actually plug it into the formula. Let's test it. Negative b, so b is currently negative 6. I'm going to put in negative of negative 6 over 2 times a. A is the number in front of x squared, which is currently 1. So I'm going to write 1. So you actually get 6 divided by 2. And I was right. The x coordinate is 3. But that doesn't tell me what the turning point is. I just now know that the turning point has an x coordinate at 3. I need to find y. And like I said before, sub x equals 3 And you would get 3 squared minus 6 times 3. 9 take away 18. Negative 9. So that tells me y must be negative 9 when x is 3. So putting together, 3, negative 9, let's say it's down here. Here's my turning point. 3, negative 9. Sketch the graph. Now, as a pro tip, to make your quadratic graphs look better, don't put in the points first. Once you've solved it algebraically, draw the graph, then put in the points. Because drawing the graph first always makes it look nicer. If you put in the points, you'll find that your lines will feel a bit wonky because you're trying to match them. Okay, so pro tip, sketch it first, then put in the points. Okay? How's that one? Pretty good? That's the same technique you're going to do for all of the examples I'm going to do. You still need to go through all these steps. The difference between each one is this step here. X-intercept is the hardest one. Exercise 3B is the variety of different examples that you could get, and you need to know how to factorize them. So it could be DOPS, it could be completing the square, it could be cross method, it could be just factorizing as we just did here. That's what you're training for. Every one of you should be able to find y-intercept, and every one of you should be able to find the turning point just simply using a formula. But if you learned completing the square, you could get to the turning point very quickly, and if you know all your factorizing skills, you can get the x-intercept quickly. Okay? All right. Let's have a look at the second example. So I'm just going to leave that roughly there so you can see. Second example, same thing. The first one I like doing is the y-intercept. Just look at the equation. That's a general form. General form is nice because you can find the y-intercept very quickly. What is the y-intercept just by looking at it? What's the y-intercept? Yes, that is correct. For some reason I thought it was 4. Yes, you're right. It is 3. So if x was 0, y has to be 3. You don't really need to do much calculations there. I'm just going to put 0, 3 there. So you got y-intercept. Next one. You can find the turning point or the x-intercept depending on your strengths here. For me, I think x-intercept will be easy because you can factorize this quicker. X-intercept. You don't know what x is, but you know that y has to be 0. So you're trying to solve for 0 equals to x squared plus 4x plus 3. You're going back to exercise 3C. So, factorize it for me. Who am I going to pick? Let's go with Artie. Have a go with this. X squared plus 4x plus 3. You use cross method or whatever method you like. I don't care. But I want to know the correct factorization. X squared plus 4x plus 3. What should go in the brackets? X plus 3 and x plus 1. Let's see. That is correct. X times x is x squared. X times 1, so that's 1x. 3 times x is 3x. So together, that will give you 4x. That's true. And then 3 times 1 is 3. So it is correct. We've now factorized it. Going back to Luke. So now we've got our two brackets. X plus 3 times x plus 1. I want to solve it. What do you do now? Beautiful. X equals to negative 3 and x equals to negative 1. How did he do that? Same thing, null factor law. You're saying something times something has to equal to 0. So one of them must be 0. So it could be x plus 3 or it could be x plus 1. You solve for it. Minus 3 on both sides. That's how Luke got negative 3. And then same thing, minus 1 on both sides. That's how Luke got negative 1. So minus 3, minus 3, minus 1, minus 1. And that's how we get x equals to negative 3 or negative 1. What does that mean? That means that when x is negative 3, y coordinate 0. Or when x is negative 1, y coordinate 0. You found your x-intercepts. We're almost there. We're just missing one last thing. Turning point. It's up to you how you want to find the turning point. Flip over to you so you get a bit more space here. You've got x squared plus 4x plus 3. You can use the formula I gave to you before. So remember the 3 methods to find the turning point. You can do it intuitively because you've got the x-intercepts already. You can do it using the formula I gave to you just now. or you can complete the square. So I'm just going to revise what we did yesterday. Let's complete the square. Completing the square means I've got x squared plus 4x, and there's this random plus 3. I want a number. That last number needs to make sure that when I factorize it, that last number is going to give me a perfect square. So hopefully you remembered from yesterday's lesson. First number clearly is an x because I needed x squared. So that has to be an x. Makes sense? What number should be in the bracket so that when I times x and then double it, I get 4? Let's go with Ben. 2. It's positive 2. So if it's positive 2, the last number must be the square of that number. So square of 2 gives you plus 4. I'm missing a plus 4. I put in the plus 4 because I want that, but that means I'm going to minus 4 because it never existed. Here we go. Negative 4 plus 3 gives you minus 1. So I'll just write it all in blue again. So minus 1. Now you can read it. You got a turning point form. Let's read where the turning point should be. What's the minus 1 do, Lillian? Yeah, in the graph. What does it tell me? Very good. So it means it goes down 1. Down 1. And then what's this x plus 2? Remember, only I teach this. No one else teaches this way. What's x plus 2? Tell me. Let's go with Jason. Very good. So it goes to the left by 2. And again, if you've forgotten how to do it, let what you're squaring, because it's quadratic, whatever you're squaring, let it equal to 0. If you let x plus 2 equal to 0 and solve for x, you get negative 2. Negative 2 implies that you're moving to the left by 2. So with that piece of information, you can actually figure out where the turning point is. Left by 2, down by 1. Here we go. That's your turning point. Negative 2, negative 1. That's how easy it is. Yeah? So again, you can do completing the square. You can use the formula I gave you, or you can use intuition. It's up to you. Depends on how fast you are. Now, pro tip again, I said sketch it first before you label, yeah? So let's have a think. Your y-intercept is at 3, so it should be a 1 on the positive region. Your x-intercept is both in the negative region. So when you draw it, this is what I would do. Just like that. Okay, so I just make sure I draw it first, because if you do it first, you're more likely to get a nice shape. Draw the arrows at the end, and then label it. So we go, this is now negative 1, 0. This is now negative 3, 0. And the other one is 0, 3. Turning point, which we figured out was negative 2 and negative 1. Obviously, mine's a bit off scale there, but labeling is key. But it makes your shape look better. So next time when you do it, just don't do it as fast as the way I just did, because I can see the scales are so off. There's 3 is so little, and yet negative 1 is so wide. Okay? But you get the idea. If you sketch it first, your shape will look better. If you try to put the points in and then sketch it, it'll look a bit funky. Okay, and because you get marked on your shape, you want to make sure your shape looks good. Okay? Don't do this. I don't want to see that. You'll get penalized. Okay, that means that you're implying there are multiple graphs in between. Right? So even though it looks beautiful at the end of the day, you're doing that, examiners will consider that as you're drawing multiple graphs in one, and they don't consider it as sketching. Okay, so when you sketch, it's one nice continuous curve. Don't do that artsy sketch. Right, they'll penalize you. All right, there we go. How do we feel so far? That's exercise 3F. Good? I'm going to give you a bit of time. I want you to try the next example. Have a go. This is your shot now. This is your time. I'm going to pause. And let's see if you can get the graph correct. I'm going to pause it. All right, team. So, what you should have found out is that as you try and cross method, it probably wouldn't work. What's a tip? You know when you get negatives, watching, eyes and ears towards the board, see that negative? When you're trying to solve for x-intercepts, what's beautiful is because it's equal to 0 and it's an equation, what I usually do is I just get rid of the negative by multiplying every term by -1. I just like working with positive x squares. Okay, that could help for some of you if you don't like the negatives. So from here, I would then have 0 is equal to positive x squared plus 5x plus 6. It's an equivalent equation. There's nothing wrong with that. Okay? And this only works because I'm solving. So I can change the equation because I'm solving for x. So here, why I like the positives, because then now I can test with my cross method. And you probably would have realized that there's an issue. To get a 5, I'll likely need a positive 6 and a minus 1. Or I can get positive 2 plus 3. Problem with both is that if you multiply them, this will give you a positive 6, which is, oh, actually, that works out. And then 6 minus 1, so it can't be this one. Oh, can I factorize it? Yeah, actually that works. X plus 2 plus 3.
So what happens if you add the negative back in?
No, because I'm solving, it doesn't matter about the negative. So
You know how you like put it out, you put it back in, and it will be the same as if you had it left them in?
yep. So another way is that you could take out negatives as a common factor. You can take out negatives as a common factor as well. This is how I would have done it. So let's solve. You should have got x equals to negative 3 and x equals to negative 2. So therefore, negative 3, 0, negative 2, 0. Y-intercept is at negative 6. And turning point, I got turning point as, by completing the square, left by 5 on 2 and up by a quarter. So that means left by 5 on 2, so negative 5 on 2, up by a quarter, let's just say it's around here, and you've got negative 2, negative 3. So that must mean I'll be drawing it like this. Maybe it should be closer like that. There we go. 0, negative 6, negative 5 on 2, a quarter, negative 2, 0, and negative 3, 0. Doesn't matter which approach you would have done it. You could have done the formula, but you all should get those 3 key features. Y-intercept, x-intercept, and turning point. What might have been tricky about this example was the negatives. And my tip for it is, if you don't like negatives or it's not something that gels with you well, get rid of them. It's okay when you're solving. Okay, when you're simplifying, that's different. You can't just get rid of a negative. In my case, because I'm solving, it's okay. Okay, so when you're solving, you're trying to eliminate your problems, so hence you simplify the problem. Whereas simplify an expression means that everything has to still stay there. You're just changing the look. Okay? All right, how do we feel about that? So far, so good? So that's probably more challenging as you're doing exercise 3F. Find the ones like this, because it really practices all your skills from 3B all the way to pretty much 3F. So A, B, C, D, E requires these skills in order for you to do what I just did. So I'm using completing the square, I'm using cross method, I'm using a bit of flexible thinking and how I would problem solve it. Okay? That's why 3F is really good. If you can do 3F really well, that means you've mastered the previous skills. And that is year 10. Okay, so what you're seeing right now, that's what they expect when you guys come in. You should be masters of year 10, meaning you can do what I just did. Okay? Now, here's your last example, and I'll probably continue with the 3G next lesson as well. Otherwise, I'll spend too much time sketching with you. But can you flip over to exercise 3G? I'm going to sketch it for you, so you don't have to do the thinking on how to sketch it. I want you just to understand what 3G is going to be about. Okay? Now, notice that on 3G, I wrote here, the best way to solve inequalities, and I want you to remember this, 3G, for quadratic, you must sketch the graph first. Okay, I'm going to highlight that. You must sketch the graph first. It's not like linear, how you did linear, you can solve it algebraically. This one, if you try to do it algebraically, you're going to do it wrong. Okay? So, here's an example. You know how we were doing this just now? When it's equal to, I'm going to highlight it. Equals is a powerful symbol. You're saying, I want to know x squared minus 2x minus 8 when it equals to 0. But what is that 0 representing? You need to understand this is your y coordinate. That's when y equals 0. Now, if you look at your y-axis, this is your y-axis. When is y 0? Well, 0 is literally right here. So this is why, when you say y equals 0, you're questioning on this graph, when does it actually equal to 0? And that's why it's your x-intercepts, these points. That's what equals means. It means that at that exact point, the y-coordinate is exactly 0. Here's the problem. When you start doing inequalities, you're not thinking about just equals anymore. You're looking at a range of possibilities. When you say, when can this graph, okay, this is the graph. When can this graph be greater than, less than 0? What they're asking is, if y is going to be that 0 point, and we know it's right here, we're asking, when is the graph less than that value? Now, when is that graph less than y equals 0? Well, if this is the line y equals 0, the graph is less down here. So I'm going to highlight it. This is when the graph, I'm going to highlight it. This is when it's less than 0. Can you see that? All these coordinates here, the y values is less than 0. Y is less than 0. No matter which point you pick, all of this will have a y value less than 0. This point here would have a y value less than 0. So how do you answer your question? This is what you would say. So if I asked you, between which points on the x-axis will guarantee that the y values are less than 0? So on the graph, between which points would I have to guarantee that the y value is going to be less than 0? What would you say? So on my x-axis, if you're looking at it, which interval would guarantee that my graph is below the x-axis? Or below 0? Does anyone see it? Okay, I'm going to show you. So I can see a lot of you are a bit confused there. This is very common. That's why I'm just going to show you here. The values that you're looking for, I'm going to highlight here so you can see, is actually any number between -2 and 4. Can you see that? This is -2 right here. And over here, this is 4. Now, these are your x-axis values. So what am I trying to say? Here, I'll show you. Let's type in the equation. I gave you, let's define. Remember how I taught you to define? Menu 1, 1. So I go to menu, actions, define. So I want to define the function. The function is x squared minus 2x minus 8. X squared minus 2x minus 8, right? What I can see on the graph is, what if I want the value to be less than 0, right? Well then here, if I picked any number, can you see any number between -2 and 4, clearly the coordinates all have a y value less than 0 on the graph. So I can test it mathematically. Let's say x was 1. That's between -2 and 4. So if I sub 1 in, if I sub 1 into the equation, 1 squared minus 2 times 1 minus 8, this is what I'm going to get. I get a -9. That's less than 0. Let's pick another one. What if I said f is, 2.3? See, 2.3 is between -2 and 4. I promise you the answer is going to be less than 0. So here we go. Oh, sorry. It's hard to see, but -7.31. That's not a guess. That's because I can tell from the graph that if you pick any x value on the x-axis between -2 and 4, the y values, because the graph shows, the pattern is that the y values are always going to be less than 0. Does that make sense? A bit more? Because when you're working for the y-intercept, what are you saying? The y-intercept clearly occurs, I'm going to show you here again. The y-intercept, not the y-intercept, the x-intercept occurs when x is exactly -2, then the y will equal. That's a different thing, yeah? And this is when x equals 4, the y will equal 0. So that means if I subbed in f of -2 should be 0. F of 4 should be 0. because that's when y equals 0. But if you want it to be less than 0, well, clearly, according to the graph, if I want it to be less than 0, this is the only section in the graph that is less than 0. Because all the y values, if you just look at the y-axis, all these points will have a y value less than 0. But then what x values would I have to put into the equation? Well, the x values are anything between -2 and 4. Sorry? You're picking all the possible x values to make sure that the graph is less than 0. Yeah? Whereas if I flipped it around, if I said, I want the graph to be greater than 0. Looking at the graph here, I can tell that this here will have a y value that is bigger than 0. This one will also have a y value bigger than 0. And just from the graph, I can already tell if you picked any number that's bigger than -2, or so smaller than -2, or any number that's bigger than 4, you're going to get a y value greater than 0. So here we go. Let's test it. If I go back and I said, let's go f of -3. It's 7. It's bigger than 0. F of -10. It's 112. Still bigger than 0. Or if I went the other direction, if you're looking at the graph here, if I chose any number in this region here, the point on the graph will have a y value bigger than 0. So say I pick 5. F of 5, if I sub 5 in, it's bigger than 0. And this is what the skill is in exercise 3G that's very confusing for a lot of students, because you learn to sketch what is equals to, but you don't actually understand yet what the inequalities mean. You're used to understanding that this is exactly when y equals 0, but you never asked yourself, well, what values should I put for x so that y is bigger than 0? That's what you're asking. Or the other case scenario is, what x value should I put in so that y is less than 0? You're used to figuring out what x value will give you y equals 0. And that's what you've been doing. That's the x-intercept. Every time you've been doing this, let y equal 0, you're solving for the x-intercept because it's literally sitting on the x-axis. But when you're asking, what x values can I put into the equation so that the y value is not 0 and not negative, but I want them to be bigger than 0, that's what you're trying to do in 3D. Okay, so to answer the question, this one would be x is equal to -2 and 4. So that's exactly at -2 and 4. That's when the y values were equal to 0. If you're answering part B, B is saying, when will you have the function less than 0? Well, looking at the graph, when will it be less than 0? Well, it'll be less than 0 between -2 and 4. It means you can pick any values for x. So how do you write your answer? This is what you write. X has to be greater than -2, so pick any number from -2 all the way to 4. That will guarantee that no matter what number you pick in that region, so that x value region, I promise you the y values will end up being a negative, just because I can see the graph right there, right? And then same thing, part C, this is where I'll stop today's session. C, we're asking, when will the graph x squared minus 2x minus 8 be larger than or equal to 0? And what they're saying is, when will it be greater than the y value at 0? So looking at the graph, this is when it equals to, and this is when it is greater than the y values equal to 0. This is when it's greater than 0. So what x values would I have to sub into the equation to make that true? Well, clearly, pick any numbers from 4 to infinity, or from -2 to -infinity. So how do you write your answer? This is what your answer would be. If you picked any number that is less than or equal to -2, which actually means the same thing as saying -infinity up to -2, or you could pick any number that is greater than or equal to 4, and I promise you it will always be from, that's the same thing as 4 to infinity. That will guarantee, and you can test on your calculator, that the y value will never be less than 0. It will always be a positive or it's equal to 0. And that's what this skill is getting you to do, because if you get this, this is very important for 3i. So next week, when I teach through and I said that's when methods begins, you need that skill. You need to be able to look at the graph and tell me when is the function greater than a certain value and less than a certain value. And that's why I'm saying that when students can't sketch, so their factorizing, solving skills aren't there, by the time I get to 3i and I talk about this conceptual idea, that's where students give up. Okay? Because you can see where it builds up, yeah? So you have to have your A, C, D, E, F. You have to be able to sketch. That means all your Year 10 foundation is strong. Then when I go to G, I'm now still sketching because I did that on Desmos for you, but you have to sketch that yourself. And then from there, you have to analyze it. That an analytical skill is what Year 11 methods is about. And that's where it tips the scale. Okay, so next week, to be prepared, you really got to do A, B, C, D, E, F. Make sure you learned that well. Okay? All right, I'm going to stop the video there. That was a long session. It's very intense. But next session, I will carry on again and I'll do these ones so that you start to feel the idea. Okay, so really practice sketching. So then when I sketch that and I start talking about when is the graph less than 0, you start to understand what I'm saying. Okay, so build the foundation. And then as I talk about theoretical, you'll get it. Okay?